Hey y'all, as you know, I have lost my voice, so this video is going to be a little quiet. Hopefully you've already spent some time practicing and have looked through the inverse functions Desmos, but we're going to walk through these notes. So, starting with the sine function, notice our sine function is not one-to-one. Therefore, because it doesn't pass that horizontal line test, there are multiple inputs for one output. We do not have an inverse function that exists as a function. The inverse is a relation. So, in order to have an inverse function that is actually a function, we restrict the domain of the sine function to negative pi over 2 to pi over 2. So if our domain of the sine function is negative pi over 2 to pi over 2, and the range is negative 1 to 1, then the inverse function, this is inverse sine, denoted with that superscript negative 1. Be really careful. This sometimes means if you raise a number to the negative 1 power, that means the reciprocal, right? But this does not mean the reciprocal. This means the inverse, which is a little bit confusing notation, which is why there's another notation. You may see arc sine that is equivalent. So our inverse sine function, instead of existing all the way and repeating, right? In a vertical motion rather than a horizontal one, it's just one section. So our range is negative pi over 2 to pi over 2. If you think about that in context of our unit circle, pi over 2 is from 0 to that positive y-axis, and negative pi over 2 is from 0 to that negative y-axis. Notice we are not going all the way around to 3 pi over 2. It is not 3 pi over 2 to 2 pi. It is 0 to negative pi over 2. So if you're thinking of 11 pi over 6, you should instead think of negative pi over 6. If you're thinking 7 pi over 4, you should instead think of negative pi over 4. If you're thinking of 5 pi over 3, instead think of negative pi over 3. All right? That is our restriction for sine, and we call this restriction the default range of sine. So the domain of arc sine is from negative 1 to 1. We can't plug anything outside of negative 1 to 1 into the arc sine function, and we can't get anything out of the arc sine function that is not in that default range. Now, of course, there are more solutions to the intersection of the regular sine function because its real domain is much larger than negative pi over 2 to pi over 2. But this range restriction on the inverse is something we're going to have to take into account if we want the unique solutions. So the inverse sine function is denoted by y equals inverse sine or arc sine. The domain of arc sine is negative 1 to positive 1, and the range is negative pi over 2 to pi over 2. Think that's quadrant 1 and quadrant 4, but the negative coterminal angles in quadrant 4. We don't want the angles from 3 pi over 2 to 2 pi. We want the negative angles from 0 to negative pi over 2. The exact value of arc sine of negative 1, remember that means our inverses and their original functions have outputs and inputs exactly switched. So if that is true, then we know that sine of some angle equals negative 1. Well, sine is y, and that means our y value is negative 1 at 3 pi over 2. But if we're thinking about the inverse function, remember that negative 3 pi over 2 is outside of this default range. So instead of 3 pi over 2, we're going to do negative pi over 2. And I think I misspoke. Instead of doing 3 pi over 2, we're doing negative 3 pi over 2 because that's the default range of the inverse. So let's use it for sine a little bit. Arc sine of negative 1/2, you're thinking what angle makes the y value be below the x-axis by 1/2. And remember that 1/2 is the short leg of a 30, 60, 90. So I'm thinking of this picture in my brain. But again, I only want pi over 2 to negative pi over 2. So I want this one. Now, that is the smaller of the 30, 60, 90s. That reference angle is going to be pi over 6. So this is negative pi over 6. You wouldn't say 11 pi over 6, and you wouldn't say 7 pi over 6. Those are coterminal, and they are the solution, some of the infinite solutions to the equation sine of theta equals negative 1 over 2, but it is not the unique output of the inverse function, okay? Now, inverse sine of root 3 over 2. We know sine is y, so I'm thinking root 3 over 2 is the y value. Meaning, we have these reference triangles. Now, I know that the range, these are reference triangles with pi over 3s. This is true for pi over 3 and 2 pi over 3. Those are the two angles that make sine positive root 3 over 2. However, our default range is positive pi over 2 to negative pi over 2 to positive pi over 2. So we're only going to use this one, and that is pi over 3. Sine of 2, remember, what is the domain of inverse sine? That is the range of the sine function. I can't get anything bigger than 1 or less than negative 1 from the output of the sine function, unless it's been vertically stretched or vertically shifted, right? So this is undefined. There is no y value on the unit circle that is greater than 1. So the inverse function is not defined for an input that's greater than 1. If you want to use arc sine, if we have a fraction, this is the kind of thing you would evaluate with a calculator. So I'm going to pull over my TI emulator app here and show you where your arc sine button is. Now it's the same button as sine, but right above sine is inverse sine written in blue. So I hit the blue second button first. Inverse sine of 0.65 is equal to about 0.708. I round to 3 decimals because that's what College Board always does. All right, now let's move on to cosine. Just like sine, we have to restrict cosine because it's a periodic function. Periodic functions repeat, right? To have a period means that's how far it takes to repeat. So periodic functions have a period in which they have a unique pattern that over several periods will repeat over and over again. So our cosine function has a little bit different of a restriction because if we use that same negative pi over 2 to pi over 2, notice I still don't pass the horizontal line test. So to get a unique clip of the cosine function, to get all the values of cosine, not necessarily the full pattern, but all the unique values of cosine, we restrict cosine from 0 to pi. So the inverse cosine function, or arc cosine, inverse cosine is how we read that, not cosine to the negative 1. We read that inverse cosine or arc cosine. You can read either of those the same way. The domain of the original function was all reals, but we restrict it to be 0 to pi. The restricted domain. The range is negative 1 to positive 1. So the domain of our inverse function is negative 1 to positive 1, and the range is 0 to pi. I'm only going to get angles out from quadrant 1 and quadrant 2. So if we put in a value of cosine into the arc cosine function, we're only going to get angles out in quadrant 1 and quadrant 2 according to the default range. So summarizing, we have y equals cosine. With that negative 1 superscript, we read that inverse cosine or arc cosine. The domain of arc cosine is negative 1 to 1, and the range is 0 to pi. Think quadrants 1 and quadrant 2. If we want to find the exact value of arc cosine of 1/2, we're thinking if the cosine had an input of x, What angle input into the cosine function gives us an output of 1/2? Inverses switch the inputs and outputs. Reciprocals flip fractions. Opposite changes sign. Remember the difference between those three words. Inverses switch inputs and outputs. So cosine has what angle that gives us an output? Now, output of 1/2 is the short leg of a 30, 60, 90, right? So if the short leg is on the x-axis, again, that's our pi over 3 or our 2 pi over 3. Wait, that cosine is negative 1/2, right? So that actually isn't one of our options, but at the same x value here, there's another one that is 7 pi over 3, also known as negative pi over 3. But remember, our default range for cosine is from 0 to pi. So we're only going to choose this pi over 3. So here, x equals pi over 3. Alrighty, let's move on to some examples. Again, this is a great time to pause, check your understanding, and hit play to see where we get. So our cosine of root 2 over 2, we know that this is an output of a pi over 4, right? And since it's positive, cosine's only positive in quadrants 1 and 4. So positive root 2 over 2 would happen at pi over 4 and at 7 pi over 4, also known as negative pi over 4. But cosine has a default, arc cosine has a default range in quadrants 1 and 2. So we'll do pi over 4. And this kind of turned out to be a yucky 4, so I'll fix it. Remember, quadrants 1 and 2 for cosine. Cosine is negative 1 all the way to the left. This is at pi. That is in that default range, 0 to pi, right? Remember your default range, 0 to pi. Cosine is never negative 2, right? The unit circle does not go all the way out to negative 2, so this is undefined. Moving on to tangent. Just like sine, we restrict tangent from negative pi over 2 to pi over 2. So the domain that we're going to use for the restricted domain is negative pi over 2 to pi over 2. And the range of the tangent function is infinite. So that means our arctangent function, or the inverse tangent function, has the switched domain and range. Why did I write cosine? We want arctangent. So our domain is now infinite. We can plug anything in to the arctangent function or the inverse tangent function. They're one and the same. But we can only get angles out from negative pi over 2 to pi over 2. And just like sine, that's quadrants 1 and quadrant 4, but only negative coterminal angles, right? Nothing between 3 pi over 2 and 2 pi, only things between 0 and pi over 2, negative pi over 2. And if you're struggling to figure those out, you can always, I consider this the longer way, but you can always say, hey, if I want it to be 11 pi over 6, I can subtract 2 pi to get the negative coterminal angle, negative pi over 6. So think negative coterminal angles in quadrant 4. We're backing up to a previous set rather than going forward all the way to quadrant 4. So our notation for tangent is y equals inverse tangent with that superscript negative 1. It is not, in this case, I know it's confusing, but it's not an exponent. It's inverse notation. The domain of tangent. The domain of arctangent is infinite. We can plug any output into tangent. Arctangent, but we can't get anything out of arctangent other than angles between negative pi over 2 and pi over 2. So if I want the exact value of arctangent of root 3, I know tangent is root 3 at the pi over 3's, and it's positive in quadrant 1 and 3, but we're only looking at quadrant 4 with negative coterminals and quadrant 1. So I want the pi over 3 in quadrant 1, which is just pi over 3. All right, again, pause, check your understanding, and see where you get. So arctangent of 0, tangent is 0 when we have y over x, y is 0 and x is 1. That happens at 0 and pi, but remember our default range is negative pi over 2 to pi over 2, and pi is greater than pi over 2, so we're just going with 0. 0, 0 is a point on the tangent function. So it will also be a point on the arctangent function. If I want inverse tangent of negative root 3, we already talked about the root 3's being the pi over 3's, but tangent is negative in quadrants 2 and 4. So I'm usually thinking on my unit circle 2 pi over 3 and 5 pi over 3. But remember, 5 pi over 3 is greater than pi over 2. So that's not the answer I'm going to use for my inverse tangent function. I want the negative coterminal angle. So I'm going to do negative pi over 3. Those are the tricky ones, and they're definitely going to show up, so be really careful. If we want to do a decimal, we can find the arctangent button on our calculator by hitting second tangent, negative 8.45. And then rounding to 3 decimal places, negative 1.453. One thing to note now that we are occasionally using our calculators to evaluate trig functions is to always check your mode. You always need to be in radian mode. We are never using degrees in this course. College Board will never use degrees, so always be in radian mode. If you're getting strange answers or you're getting errors you don't know how to deal with, one of my calculators may have been left in a degree mode by Math 2. So please check your modes. Our TIs in the classroom list the mode right at the top of the main screen. All right, so here are a few examples. Try them, pause, and give it a shot, and then come back and see the answers. So arc cosine being negative root 3 over 2 is going to happen in quadrant 2, and that's going to be 5 pi over 6. Inverse tangent of 1. Tangent is 1 at the pi over 4's, and it's positive in quadrant 1. Arc sine of negative root 2 over 2. Sine is root 2 over 2 at the pi over 4's, and sine is negative in quadrant 3 and 4, but 4 is our only option, so we want negative pi over 4, not 7 pi over 4, but the negative coterminal angle. Sine of negative 1/2 happens when we're at the pi over 6's, so that's going to be negative pi over 6. Arc cosine of 2 is undefined, because the output of cosine is never greater than 1, so the input of arc cosine can never be greater than 1. Arctangent of negative root 3 is going to happen at a pi over 3, and since it's negative, it'll be at the pi over 3 in quadrant 4. Inverse sine of 1/2 happens at pi over 6 in quadrant 1. An arctangent of negative root 3 over 3, we know tangent's negative in the quadrant 4, and root 3 over 3 happens at the pi over 6's, so we're looking at negative pi over 6. A couple more U-tries. Remember, the concept of composition can come back anytime. And I want you to notice this particular problem, tangent composed with arctangent. Think back to your inverse composition rule. If we compose a function with its inverse, that's the same either way. Either way we compose it, composition is not commutative. We can't do it in any order unless the two functions are inverses, and it just gives you back the input. Whatever you plugged in is what you get out. So if I compose tangent with its inverse, I'm just going to get back what was plugged in. However, if I compose two trig functions that are not inverses, I have to start in the middle, evaluate the inside, then plug that into the outside. So again, arctangent of root 3 is pi over 3. Arctangent of root 3 over 3 is pi over 6. So I'm going to replace arctangent of root 3 over 3 on the inside with pi over 6. Then evaluate cosine of pi over 6, and that's the long leg of the 30, 60, 90, so that is root 3 over 2. Arc cosine of negative 1/2, I'm thinking negative cosine is in this direction, and I'm only looking at quadrant 2, so I want the pi over 3 in quadrant 2, that's 2 pi over 3. The last thing I want to think about is the reciprocal functions. If you're trying to solve an equation like this, you've isolated your trig function and you want to solve for theta, we're not going to worry about working with inverse functions of the reciprocals because we can always just use the original 3 to solve our problem. So I'm going to convert each of these equations to sine, cosine, or tangent. Cotangent is the reciprocal of tangent. You're always allowed to take the reciprocal of both sides of an equation. So I can flip negative root 3 to be 1 over negative root 3, which we know the reciprocal of the reciprocal of root 3 is root 3 over 3. We know tangents negative in quadrants 2 and 4, and we're only looking at the negative coterminals in quadrant 4 when we take the inverse tangent, right? So when we take the inverse tangent of both sides of this equation, remember taking the inverse of both sides is what undoes a function, just like we take the square root of both sides of a quadratic. With only an x squared, right? If you isolate that x squared, you can take the square root of both sides. Same with trig functions. If you isolate the trig function, you can take the inverse of both sides. So theta is going to equal the tangent from the negative coterminal angle in quadrant 4 that gives us a tangent of negative root 3 over 3, which is going to be a pi over 6. So that is negative pi over 6. Repeating the process, maybe take a second and pause and see if you can repeat the process with secant and cosecant. All right, so let's see. Secant is the reciprocal of cosine, so we want to know when cosine is 1/2. Well, theta equals the inverse cosine of 1/2, which is going to happen in quadrant 1, and that's at pi over 3. Know your unit circle. Sine is the reciprocal of cosecant, and -1 is the reciprocal of itself. So we want to know when sine is -1, the inverse sine of -1. Usually we would be thinking about 3 pi over 2, right? But 3 pi over 2 is way greater than our default range of sine, which is negative pi over 2 to pi over 2. So instead of 3 pi over 2, I'm going to use the negative coterminal angle, negative pi over 2. So your summary here is to remember that the default range of cosine is 0 to pi, and the default range of, I should say, inverse cosine, and the default range of inverse tangent and inverse sine are both negative pi over 2 to pi over 2. All right, that is all.